Lesson 68, even and odd functions. Definitely should sound familiar. We definitely talk about them in pre-cal. Did we talk about them in Algebra 2 maybe also? I don't remember. It's been a few. It's not occurring to me, but definitely a pre-cal topic. So we're going to talk about even and odd, how to know the difference, and how they can help us. Okay, how things, how these information can help us. So, an even function. An even function is a function that for all values of f of x and f of negative x are equal. So if you recall, there's an algebraic way to determine if something is even or odd. And algebraically, it's f of x equals f of negative x. This also means that the graph of f of x is symmetric about the y-axis. So there's also a graphical way to tell if something is even, and that is having that vertical y-axis symmetry. Okay, so even, f of x equals f of negative x, symmetric across the y-axis. An odd function is a function that for all values of f of x negative x equals negative f of x. You'll remember that's usually the one we check secondly. And then this also means the graph of f of x is symmetric about the origin. It's kind of a diagonal symmetry. I also kind of compare it to like a 180 rotation, where if you take like quadrant 1 and you flip it down and also flip it across, you end up in that, diagonal third quadrant there. It's also what I just talked about, how it's two reflections, reflecting across the x and the y. Okay, so that's even and odd. Example 1 is the function f of x equals x to the fourth plus x squared minus 6, an even function, odd function, or neither.
I'm guessing even, or I'm not guessing even. I'm saying even because the power on x would be positive. So it would end up being, if you put like a negative x in there, negative that to the fourth would be positive that number. So I think it's even.
Okay, so one option, if we think algebraically, the idea of if I try and find f of negative x. Remember to find f of negative x. You put every place you see an x, you replace it with negative x, right? So instead of x to the fourth, it would be negative x raised to the fourth plus negative x raised to the second minus 6. So mathematically, that's what we're doing here. If we actually work this out, a negative x raised to the fourth. Well, what's a negative raised to the fourth? That is positive. Negative x raised to the second. A negative raised to the second is positive. And minus 6 is still minus 6. What just happened? Yeah. We just showed algebraically that f of x is equal to f of negative x. And if f of x is equal to f of negative x, that means this is even. Also means you have to go no farther. You don't have to check negative f of x if you are confident in these calculations here. Did anyone graph it? Okay. Because I want to talk about it just while we're here. What's the graph show?
Well, it looks like a nifty little parabola.
Looks like a nifty little parabola. Technically, it's an x to the fourth, so it's probably a little wider looking at the base, technically. But it looks parabola-ish, yes? Is that parabola centered along the y-axis? Yeah, so we could take our graph, fold it at the y-axis, and there's my just basic sketch. But the idea is there's a line of symmetry right here, so the graph also proves. I strongly encourage you guys to be familiar with both. Don't just rely on the graph because you don't always have access to the graph. So understanding the algebra is, in my opinion, just as important as understanding the graph. Okay, good pre-cal review there? Because we did exactly that in pre-cal, didn't we? Okay, example 2. Is f of x equals x cubed minus x an even function, odd function, or neither? Well, if I start algebraically, what am I going to do first? See what happens when you put negative x in. So if I write this out, that is the negative of x raised to the third minus the negative x. What about negative x raised to the third? It's going to be negative x to the third minus negative x, so plus x. At this moment, I know it is not even. Okay, f of x definitely does not equal f of negative x. So I know it's not even. So now I'm going to find negative f of x. Do you remember what negative f of x means? Yeah, multiply the whole equation by negative. Basically, you're taking a negative and distributing it to each term. So then I end up with negative x cubed plus x. What just happened? F of negative x and negative f of x ended up equaling, didn't they? So when f of negative x equals negative f of x, we know that it is odd. Anyone look at the graph? Your graph looks like a cubic, doesn't it? Of course, the real graph is better, but looks something like that. And so for visual effect, that is an example of something symmetric across the origin. You can take the graph and rotate it 180, which basically means taking each quadrant and rotating it in 2 quadrants. You could also take, like if you take one side of the graph and, flip it across the y and then flip it across the x, so flip it upside down, think about those relationships there. So for multiple reasons, you can hopefully see that it is even. Okay. Questions there? Evaluate the following integral. I was just talking about all these heavy integrals we're getting a break from today, but yet we're not really getting a break. We're still going to throw.
Either way.
Huh?
I said I wasn't either way because there's a bunch of integrals in the test.
Okay. Evaluate the following. The integral from negative 1.5 to positive 1.5 of x cubed minus x dx. Shall we evaluate it and see what happens? I was debating if I wanted to talk about the graph now or later, but I think we'll go ahead and evaluate it and talk about it. Because it just says evaluate the integral, right? It's not in the tense of find area or anything like that. It's just evaluate the integral. So let's do just that. integral of x to the third. Okay, add 1 to your power and divide by that. So 1/4 x to the 1/4 1/4 x to the 4th minus integral of x. Add 1 to the power, divide by it. 1/2 x squared evaluated from negative 1.5 to positive 1.5. As I do this, and I wrote it as 1/4 x to the 4th, but I'm also going to make it look a little bit neater. I'm going to say 1.5 to the 4th divided by 4. Does that work for you guys okay? I'm putting in the 1.5 that is, minus 1/2 x squared, so that's going to be 1.5 squared divided by 2. Minus, and now we are plugging in negative 1.5 raised to the 4th divided by 4 minus negative 1.5 raised to the 2nd divided by 2. Thoughts here?
So negative would make that positive, right, on the other side eventually. This will come out of the negative, right? Or no, it won't, because they're even.
Because I'm going to argue we can do this one without the calculator. In that, okay guys, 1.5 to the 4th divided by 4. What do you know about negative 1.5 to the 4th?
Oh my goodness. It's the same thing.
It's going to be a positive, right? Negative 1.5 to the 4th is the same thing as a positive 1.5 to the 4th. So what's going to happen with these guys? 1.5 to the 4th divided by 4 minus, well, he's going to become a positive, right? So those are going to end up canceling. What about the others? This is negative 1.5 to the 2nd divided by 2. Well, this is minus negative, so it's really adding. What do you know about negative 1.5 to the 2nd? It's going to be the same as positive 1.5 to the 2nd. What's this going to all work out to be? 0.
And I take it the graph is, it would actually, no, because it's like the hump here and the hump here, right? So it's 0.
Mm-hmm. Okay. What is this graph going to be, even or odd here? If it works to be 0,
Oh.
it's going to be odd. Okay. Ross was talking about the opposite hill and valley, if you will. Okay. And so those are going to end up, when you have an equivalent shape above and equivalent shape below the x-axis, they end up canceling each other out, right? It just said find the integral. Did it say find the area? No, if it would have said find the area, we would have had to break this up into pieces. And so if I give you a little sketch of the graph, yes, it's something like this. And then, and you guys, of course, can, it ends up where negative 1.5 is over here, positive 1.5 is over there. So officially, we're going from here to there. But when you look at that area under the curve, it'd be this area canceling with that area, and that area canceling with that area. Okay? So thus, recognizing that as an odd function can play an important role there. And that, you notice we went from negative 1.5 to positive 1.5. We went from negative 2 to positive 2, negative 3 to positive 3. They're all going to end up 0 because they're going to cancel each other out. It just asks for the value of the interval, so 0 is the appropriate answer. As I said, if they had instead threw the word area at us, then I would have been doing 2 of those pieces and doubling them, and I would have been making somebody negative and all of that. Okay. Questions on that one? Did it all come together by the end for you? If so, I'm ready to look at the next one. Is g of x equals x to the third minus x minus 4 an even, odd, or neither function? So what am I checking? G of negative x. So negative x raised to the third minus negative x minus 4. What does g of negative x clean up to be? Negative x raised to the third is still going to be negative x to the third. Minus negative x is plus x minus 4. So once you find g of negative x, we know that this function is not even at this point, because g of x and g of negative x are not the same. Okay, so now I'm going to find negative g of x which means I'm going to distribute that negative. When I distribute that negative to all my terms, I end up with negative x to the third plus x and plus 4. So it's not odd now either, because g of negative x and negative g of x don't work. They're not the same. And so what do we have here? This is a neither example. I don't know, is this maybe a little easier than it was a year ago in pre-cal? It would have been over a year ago in pre-cal, because this is first semester.
But I remember taking the test, and I was like, I don't know how to tell if they're even or odd.
This is like part of chapter 1 or 2, and it's a struggle in pre-cal.
Think back to parabolas, like how we know we couldn't do those, but now like we just see a parabola, like, oh sweet.
Thinking about foiling, I remember I wanted to throw up in algebra. I was like, this is factoring. Yeah, I know. I'm like, oh, okay.
What's my issue with that was that I did on spell foil.
However, if you reverse the O and the I, it still works out the same.
I
No,
know,
he switched
I can
the
never
L by F.
I never
He was
follow
always
examples though, because like I would do it the opposite way.
You get confused.
It's okay. He wants to be the English teacher.
Wants to be in English. Oh, how the
Okay,
terms
guys.
use.
Let's throw in some trig with our pre-cal here.
Spice it up.
Yeah. Is y equals negative 3 tangent of 2 pi x an even, odd, or neither? Now, we would not have dealt with trig functions along with our even, odd, and neither stuff, because we did even, odd, and neither back in chapter 1 or 2. Trig functions didn't come up till chapter 4. Okay? So, same rule applies. How do we figure out if it's even? It's going to be negative 3 tan of 2 pi times negative x officially, right? In other words, I'm putting in negative x. Now, if I clean that up, I guess, negative 3 tangent, 2 pi times negative x is negative 2 pi x. Huh? Well,
The negative outside, that negative inside cancel.
Does it?
I'm trying to think how I want to explain this. I don't have anything about how I've...
Plus.
Sorry, I'm pausing for a moment trying to think how I want to explain this because... I guess that is probably how I want to go. Sorry, I'm really spacing here. That negative 2 pi x I guess I want to say because it's tangent, we can take that negative out front. So I don't know if you remember, ironically enough, they are even-odd identities. This is exactly what it relates to. Okay. The even-odd identities said that tangent of negative x is indeed equivalent to negative tangent of x. Okay. So you do, when it's tangent and sine, you have that ability to pull it out front, and it makes it a negative. But since we already have a negative there, it's going to make it actually a positive, because a negative times a negative is a positive. And so this does become positive 3 tangent of 2 pi x. If you remember the even and odd identities, tangent and sine made the function negative. Cosine keeps it positive because it's an even function. Okay? So right here, negative 3 tan of 2 pi x does not equal 3 tan of 2 pi x. So we know that this is not even. Let's try odd. Y equals the negative of negative 3 tan of 2 pi x. Okay? Well, that one's easier to work with, isn't it? Negative times negative is a positive. So that's 3 tan of 2 pi x. What just happened?
We proved it was opposite.
Yeah. These guys are equal to each other, aren't they? And since they are equal to each other, they are odd. Okay. Example 6. F of x equals e to the x, even, odd, or neither? Well, what do you know about f of negative x? It's going to be e to the negative x. And then what about negative f of x? Negative e to the positive x? So what do we know about this with this e to the x? It is neither even nor odd. They do not match up there. What changes when we throw a squared up there?
Keeps it the same.
So f of negative x is going to be e to the negative of negative x squared. That is if I write out all the little negative x squared is positive x squared, but the negative of that makes it negative x squared. And so by definition, we know it is even. Could you graph any of these on the calculator you want? Definitely. Okay. Feel free to grab that calculator and check out the graphs. It's kind of a backup proof in a way. You know, you check your algebra and you're not 100% sure, then you can check the graph. Okay. Example 7. Last one, I believe, because we're just on the front side today, right? Yep. Okay. Is g of x equals x squared plus cosine x over sine x an even, odd, or neither? Now, side notes. What side notes are we going to need to know here?
The cosine is the sine is odd.
Yeah. When you see cosine of negative x, remember that cosine of negative x is just equal to a positive cosine x, whereas sine of negative x is equal to a negative sine x. Okay? Those were part of our even-odd identities that we did into pre-cal. That's like chapter 5 material, I would say. So let's check this out. Or maybe you guys are already done and ahead of me. Okay, g of negative x, what do we figure out? Negative x raised to the second plus cosine of negative x over sine of negative x. Negative x raised to the second is positive x to the second. Cosine of negative x? No. Plus cosine x. Over sine of negative x? This one is negative sine of x. Okay. Does that match with g of x? Nope, because we don't have a negative in there anywhere, do we? Now, this next one. Negative g of x. Officially, that is a negative distributed, right? So in this case, it's a negative times the fraction of x squared plus cosine x over sine x. When we talk about a negative times the fraction, how do we deal with a negative times the fraction? You can multiply by the top, or you can multiply it by the bottom, but not both. Think about it. Multiplying by negative 1 is either multiplying by negative 1 over positive 1, or multiplying by 1 over negative 1, yes? If I multiply both top and bottom by negative, I've now multiplied by a positive. So in this case, if we want to make this look the same, where would I want to multiply this negative into? The bottom, and then what do you know? They're the same and it's odd. Do you see what I'm saying there? So in a situation like that, you really kind of have to look at the whole problem and decide, do I multiply it into the top or the bottom? Okay, I would even just stop here and point out that these guys are going to be equal, and so it's going to be odd. And that's because I could multiply the negative into the denominator. Now, if you're going to say, well, but I choose to multiply it in the numerator, they're not equal. But keep in mind they would be equal. Because if I multiply that negative into the numerator, just means all my signs are exactly opposite. And when all your signs are exactly opposite in a fraction, it is equivalent. Okay? Okay. Pre-cal review with some calc thrown in there. Technically, it really is pre-cal. I mean. Okay.